My name is Doug Clark. I'm a professor and Centennial Research Chair in the School of Environment and Sustainability at the University of Saskatchewan. My research looks at mostly decision making in northern wildlife management contexts. So a lot of the work I do is with communities on particular issues or in response to particular issues that come up. One issue I'm doing a lot of work on these days is polar bear human conflicts, and one project as part of that research emphasis involves monitoring polar bear visits to field camps in Wapisk National Park in northern Manitoba. So the primary tool in data collection for this project are these trail cameras. And what this is a motion-triggered camera. And every time an animal walks by, this camera takes 3 pictures. And each photo is date and time stamped, and other information like the temperature, the phase of the moon is all collected along with that. So we have all of that data tagged to the photographic record of what walked by. These cameras were originally not developed for research. These were developed for hunters to be able to pattern white-tailed deer. And one company, Reconyx, which makes this one, seems to be the front runner at the moment in high-end cameras. And this is a research model, which is more or less exactly the same as the high-end one sold to hunters. It has an infrared flash, so it doesn't disturb the animals. It runs on 12 lithium AA batteries, and these will run a full year in the subarctic with these 12 batteries all still happily ticking away. It just takes a regular SD memory card, just like any other digital camera, and it records all the information there. So we have to show up about once a year, switch out the memory cards, change the batteries, and the cameras just keep on ticking. And just they've proven themselves to be enormously reliable. These are fun right now. The data you get is really visually appealing. Everyone can see what's going on. These are becoming extremely popular, not just in the research world, but hunters, naturalists, photographers, journalists, all kinds of people are using them because they keep working and they just stay awake and taking photos when you're not around. And it's fascinating what they do reveal. You also can see a whole lot of other phenomena for which understanding the timing over time is really important. So the timing of plant green up, flower emergence, when the plants die off, that's known to be shifting as the climate warms up there. So being able to monitor that inexpensively with tools like this would be extraordinarily useful. Things like when the ice melts out on a lake, when a river breaks up or freezes up again, these cameras would be able to, just put on time lapse, be able to catch those dates very precisely. So there's a whole suite of biophysical phenomena that can be measured with these cameras, and we're just all still in the early stages of exploring. There are a couple of things that we have in mind. One is just pushing the techniques a little bit more and seeing what we can do. This is a camera that's configured for winter use. So from the side you can see it doesn't have that little scrim over the infrared flash, which picks up snow like the basic camera does. It's got just a plain sheet of glass, so the lens and the motion sensor won't pick up snow. So this camera probably will be a little bit more reliable in terms of providing really good quality images year round. So we're really interested in that.